Hello, I'm Andy, and this is Space Reviewed, an introduction to space technology through the medium of the 5-star rating system. Before I get on to reviewing the first spacecraft on my list, I'd like to ask you a question. Which country do you think got to space first? You might be thinking of the USSR, whose Sputnik satellite shocked the world in 1957, but you'd be wrong. 13 years earlier, Germany was the first country in space with this, a rocket called Aggregat Vir, a prototype of the V2 named to make it sound like construction material, just in case any spies heard the name. So Germany was the first to get to space. But what does that actually mean? We all know space is up above us somewhere, but how far up? It turns out that's not such a straightforward question to answer. Let's follow the Aggregat Vir on its test flight to see why. Here's our rocket, not to scale obviously, sitting on the Earth's surface. Time to launch. 3, 2, 1. A few seconds later, and it's already 1 or 2 kilometers in the air, passing the clouds. But clouds aren't in space. A bit further, and it's at cruising height for an airliner, about 11 kilometers up, still not in space. Higher still, and it reaches the altitude record for a jet plane, about 37 kilometers, set by a Russian MiG fighter. So does this count as the edge of space? Well, no. But we're thinking along the right lines. Most people agree that space begins at the point where the atmosphere is so thin that winged aircraft can't generate enough lift to go any higher. The limit for jet aircraft is actually the engine. Wings can take you much higher. How much higher is a difficult question, because the thickness of the atmosphere isn't the same everywhere all the time. There's some room for argument, and people tend to pick on a nice round number in the right range for convenience. The US picks 50 miles, or about 80 kilometers. The rest of the world goes with 100 kilometers. This is the semi-official definition for the Kármán line, named after the scientist who first proposed the idea that space begins where winged flight stops. But it's not a legal definition. There is no international law about where space begins, which means there's a bit of a grey area between the upper limit for jet engines and the lower limit for satellites, which is actually a little bit higher than 100 kilometers. But let's continue with the rocket. It went a lot higher than this, all the way up to 176 kilometers. But it didn't stay there. To understand why, we need a quick lesson from Isaac Newton. This is a diagram from his 1687 work Principia Mathematica. Imagine you had a tall mountain, say 176 kilometers tall, and you had a cannon at the top of it. When you fire your cannon horizontally, gravity pulls the cannonball down to Earth, and it hits the ground at the point marked D. If the cannonball is going a bit faster, it goes a bit further, perhaps to E or to F. But if you keep on making it faster and faster, you eventually reach a point where, because the Earth is round, the ground effectively falls away beneath the cannonball at the same rate the cannonball falls towards the ground. It doesn't get any closer, and it ends up going in a big circle all around the Earth. In other words, it's in orbit. The speed this happens at is called the orbital speed. The Aggregat Vir rocket we've been following was fired straight up, rather than sideways, and it didn't reach the orbital speed needed to stay up, so it fell back to Earth. Of course, that's actually what it was meant to do. It was a missile, after all. So the Aggregat Vir was an impressive bit of kit. High-quality German engineering got it to space way ahead of anyone else, which was no mean feat. This was literally rocket science. But on the negative side, it was ultimately a Nazi war machine that killed a lot of people indiscriminately. For that reason, I can only give the Aggregat Wir 2.5 stars out of 5.